Hi everyone. So welcome to the third video of this playlist of Design a Web Crawler. So in the previous video, we have discussed about a high level overview of how a web crawler works. Like if you remember, we have introduced certain components or terms like it first encounters a seed URL, then puts the URLs to the URL frontier. After that, it downloads the web pages using the DNS resolver, then parses through some content checker. Then after that, once the contents are valid, we extract that URL links, filter the URL links and check whether that URL has already been visited or not. If yes, then we ignore that URL. If not, we then push that into the URL frontier and we repeat the process recursively. So now we'll look into a high level details or dive deep into the designing of web crawler. So in this video we'll be, and in the subsequent videos also, we will be looking into these 6 sections. One is DFS versus BFS. I'll be discussing right now. In this video we will be discussing these two components. One is this and the other one is URL frontier, and in the next subsequent videos we will be looking up upon the remaining sections. So without wasting any time, let's dive deep into each of these components. So first is DFS versus BFS. So what is this? So if you look into a web crawler, how it works in a high level, so if we can consider this as a directed graph, and in graph we have nodes and edges. So for nodes, what we can do is we can consider the web pages to be our nodes, and the hyperlinks between these web pages which connects from one web page to another can be considered as edges. So let's say I have a website of abc.com and there are multiple hyperlinks in that web page, like let's say it goes to 1 and goes to 2 and like that. There may be and hyperlinks present in abc.com web page, and it again correspondingly goes to some abc.com/1/1 and like that it carries on recursively. Okay, so now we know this looks like a directed graph. So in graph we have two types of traversal. One is depth first search and another is breadth first search. So DFS and BFS. So which one would be favorable? So can you guess? Like, can you just pause the video and think about which one is favorable to use here, like whether DFS or BFS? So it seems if you use DFS, since it goes in, as the name suggests, it recursively finds the longest depth till it reaches the leaf node. So what happens here, the depth can be too deep. So this is not a favorable. So like the web crawler starts from here and it goes till here, and all these links are not explored till now, and it goes to, let's say, very much huge of depth, whereas the other URLs have higher priority and they needs to be visited, and there are other also criterias which needs to be fulfilled for these URLs rather than going into the depth. So this is not a favorable idea. Whereas if we use BFS, so BFS uses a queue data structure to traverse the nodes. So this is most favorable for web crawlers. So you in a queue, whenever the order in which so this is basically, it uses a queue data structure. So in queue, the order in which a particular URL has been enqueued, it's in the same order it is also dequeued. So BFS is a favorable traversal for web crawling. But there seems to be two problems when we use BFS. So what are these problems? Like, there are two situations which might arise. One is, like you can see, most of the links of this web page link to the same host, which is abc.com. So suppose let's say the web crawler is running in parallel and it's picking up the URLs from the queue in parallel and they're processing. So what might happen is, like, a huge number of requests can go to this host URL or host server in a short span of time. So this is not a favorable situation, and this is termed as impoliteness. So I'll write down what is the current situation. Like most links in web server, in web page, link to same host. So in our case, this was abc.com. So suppose web crawler running in parallel. They're processing the links in parallel and they have been scheduled like that. So what might happen, what might happen is this: many requests are sent to the same host in short span, right? And this is not favorable. This is called impoliteness. This is not a favorable situation. So this is one of the drawback which we have if we follow this simple BFS method. Another one situation which arises, so this is problem 1. Another problem which we might face is like BFS, the standard BFS doesn't take web pages priority. Like some web page might be of higher priority rather than another URL, and in BFS we follow a first include first decode like FIFO method, and suppose abc.com/1/1 is higher prior than abc.com/2, but in BFS if you traverse, this would be visited first rather than this. So this is one of the major drawback. So we need to prioritize URL. So there are various factors on which we prioritize our URLs. So basically we do it on page rank or the web traffic which is handled by that particular URL or web page, or frequency of visiting or frequency of updation of that web page, and all that factors, etc. There are factors which handles the priority of a URL. So to solve these problems and to also handle the updation of web page, if a particular web page is updated and if that URL has already been visited, how can we handle those situation? And to solve these two problems which we encountered, like impoliteness and the priority and all those things, we have our data structure which we discussed in the high level view, that is the URL frontier. So how does URL frontier helps us? So this is so what is URL frontier? We have also discussed in the previous video. So it is a data structure that holds URLs that are not yet downloaded, right? So how do URL frontier help us? So what problem did we have? So problem we had was like, so our question is how we handle impoliteness, right? So suppose let's say the web crawler is processing in a parallel scheduling and too many requests are sent to the web server, to the same web page, and it considers maybe that as a DDoS attack and leading to IP ban of the web crawler and all. So these situations might arise. So how do we handle that actually? So what we have a solution is, the solution for this is we download one page at a time for a particular host name, domain, for a particular domain. We download one page at a time from same host, and we can also, this is one, and also add some delay between two downloads from same host. Okay, so this is one of the workaround which we could have. So we download one page at a time, not multiple pages simultaneously from the same host, and also add some delay between two downloads. So for this what we use is, so let's say we have an input URL, we have a service, let's say queue router. So queue router, what it does, it redirects the URL to a mapping table. So what does this mapping table store? This stores for a particular domain or particular host which queue it will store the URLs. So this is basically a mapping between a particular host and particular queue. So once this mapping has been done, so queue router routes the URL to particular queue. So we have, let's say, like this, we have q1, q2 and dot q n queues we have, and queue router maps this URLs once we see a input URL. So it, depending on the host's name or depending on the domain name, it maps the URL to this particular queue. So let's say, for an example, in a mapping table we have is like, say, apple.com domain will be mapped to q2, nike.com we have, let's say, it maps to q1. So all the URLs, all the hyperlinks of this domain will be mapped to q1. For nike.com, for apple.com, it's mapped to q2, and like that. And after that, once this input URL has been mapped to the queue, so how to read those or how to download those? For that we have worker threads. So this is, let's say, worker thread 1, worker thread 2, and like that we have also n worker threads. So these worker threads, what they do is they have 1:1 mapping with the queues. So only one particular worker thread will interact with only one queue only. So like worker thread 1 maps to handles the requests of q2, so it won't handle the request of q1 or any other queues. So any request coming from q2 will be handled by worker thread 1, for an example. So for that, what we have is a queue selector. So it randomly selects the URLs present in the q1 or q2 and all the other queues, and then maps those URL to the corresponding worker thread to handle or to download the web pages. So in this way, and we also add some delay. So let's say we add some delay in between two URLs of the same host, and thus in this way we handle the problem of impoliteness. So this is a situation of handling the impoliteness, or you can say this is politeness. This was our first problem which we encountered in web crawling, or when web crawler performs in parallel and huge amount of requests are sent to the same host page in a short span of time. So this is one workaround for politeness. Second thing which we also discussed is like standard BFS doesn't prioritize an URL. So by prioritizing, what do I mean is like, suppose a URL, in a URL we have, or a web page is dedicated to random Apple accessory discussion. Okay, and another web page is there. This is the apple.com or Apple's home page. So both the web pages have Apple as its keyword, but as you can guess, or as you can see, this web page is a higher priority compared to some random web page which discusses about Apple products. So how can we prioritize these web pages? So web pages are prioritized based on various factors such as the page rank. So I will put links about all these things, page rank algorithm, and how does these things work in the description box. You can read more about them. How much frequently these pages are updated, update frequency, or how much traffic these web pages handle in a particular period of time. So all these things are used, all these things factors are considered for prioritizing a URL. So how do we handle this URL prioritizing? For that, what we use is a prioritizer. So what is a prioritizer? It takes an URL as input. So I have a prioritizer, let's say prioritizer. It takes an input URL and it computes priority of the input URL. So after the URL has been, the priority has been computed, it distributes this input URL based on its priority to various queues, and each of these queues, mind you, have their own priority. So let's say they have, so q1 is higher prior than q3 is higher prior than q2, and like that they have their own priority, and depending on the calculation of the input URL's priority, it is mapped to the corresponding URL. And once this mapping has been done, again we have a queue selector. So just like we saw in the above example also, so this queue selector randomly selects the URLs present in the queue with a bias. So this randomly selects, although it randomly selects URLs from the queues which have its priority. So I'll name them q1 dash, q2 dash, qn dash, not to confuse with the above queues. So these are different because they have a priority in them also instilled. So randomly it selects URLs from q1 to qn, but it has also some bias with higher priority queue. Okay, so in this way URL which is of higher priority is being redirected. After this URL has been redirected, we can follow the method of downloading the URLs just as we discussed in order to avoid the condition of impoliteness. So what it does is so URL frontier, so basically URL frontier is made up of two sections. One is called front queue, which we just discussed in the priority section, and this second is called back queue. So front queue, so this handles priority of URLs, and this handles the politeness. So how can we connect them? So once we are in the queue selector, after the queue selector selects the URLs from the priority queue, it follows this output URL is now next sent to this back queue which we just discussed, which is queue router and the mapping table, which then maps the, depending on the host name, to the particular queue. From that queue we have that queue selector which selects the URLs, and then it redirects to the worker threads to finally download the URL. So in this way it handles the entire scenario. So another thing which we also can look into, which is handled by this URL frontier, is called freshness. What is freshness? Freshness is how much time or what is the frequency, how much time or frequency in which the URL is updated. So web crawler, what it does, it recrawls downloaded web pages periodically to keep data fresh. So how we can handle this situation? So we can handle like recrawl the web pages based on its updation history. And second, what we can do is we prioritize URLs and recrawl more important pages. So in this way we can handle the freshness. And another thing is like, how does the URL, what is the storage for this URL frontier, since millions of URLs are present for a particular web page, or in the over in the internet, hundreds of millions of URLs are present. So how do we handle the storage? So storage is handled efficiently. Like what we do is, it's a disk plus memory. So most of the URLs are stored in disk, but disk IO is slow. So for what we do is, we take the help of memory. So in memory what we have is buffers, which helps in NQ or DQ operation. And whenever this memory is full, if the data in buffer is full, it is flushed to disk. So in this way, URL frontier, which is an important component after the seed URL, handles the incoming URL request which needs to be downloaded, firstly prioritize the URL which needs to be downloaded first, then handles those domain host names so that huge number of requests cannot go to the same host in a short span of time. For that it uses a back queue, which handles the situation is like, it checks in the queue router in the mapping table, checks the queue where it should be mapped, and after it is mapped, it is sent to the worker thread by the queue selector to be downloaded. And it also handles the freshness situations, like whenever the URL is updated frequently and how they can be handled. And finally, this storage is using both disk and memory. Initially, for faster read and writes, to enable NQ-DQ operation, we store the data in buffers in memory. If the data is full in buffer, it is flushed to the disk. So in the next section, we will be discussing about the HTML downloader, the robustness, the extensibility, and all other deep designing topics for this URL crawler. So thank you for watching this video. I'll see you in the next video.